So the endocrine system's main overall function is to maintain homeostasis in the body via the use of hormones. So what is a hormone? A hormone is a molecule that's released in one part of the body and it's going to control activity in another part of the body. So what is a gland? A gland is an organ that releases a secretion. Glands can be either exocrine glands or endocrine glands. Exocrine glands are ducted glands and their secretions vary a lot. It could be saliva, they could secrete milk, or even enzymes. Endocrine glands are ductless glands and they release only hormones. So your glands could be stimulated in 3 different ways, which would cause secretion of possibly hormones. The gland stimulation could be humoral, which means change in the levels of ions or nutrients. It could be neural, which could mean neural input from the sensory receptors, and it could be hormonal, which would be the change of hormones. The hypothalamus in the brain is kind of like the brain of the whole endocrine system. It's going to give directions to the posterior and the anterior pituitary glands. The infundibulum is just the connection between the hypothalamus and the pituitary glands. So first we'll just talk about the anterior pituitary gland. The hypothalamic neurons are going to actually make the releasing hormones, which will be sent down the infundibulum to the anterior pituitary gland and tell the anterior pituitary gland which other hormones to release. So there's multiple releasing hormones that are made in the hypothalamus to be sent to the anterior pituitary gland. These releasing hormones are called thyroid-stimulating hormone releasing hormone, adrenocorticotropic releasing hormone, gonadotropin releasing hormone, growth hormone releasing hormone, prolactin releasing hormone, or prolactin inhibiting hormone. These 5 hormones that are made in the hypothalamus will cause a release of other hormones that are in the anterior pituitary gland. So for example, thyroid-stimulating hormone releasing hormone made in the hypothalamus will cause the release of thyroid-stimulating hormone in the anterior pituitary gland. So thyroid-stimulating hormone releasing hormone in the hypothalamus will cause a release of thyroid-stimulating hormone. Thyroid-stimulating hormone will be sent to the thyroid gland. So calcitonin will be released from the thyroid gland. It's stimulated due to a high blood calcium levels. It will inhibit the osteoclast, which will decrease the calcium levels and phosphate as well. I like to imagine it as calcitonin wants to save the bone, so it's going to tell the osteoclast, stop breaking it down. So thyroid-stimulating hormone from the anterior pituitary gland can also cause a release of T3 or T4 in the thyroid gland. T3 and T4 released from the thyroid gland has various different functions. They can increase your basal metabolic rate by increasing cellular respiration. They can affect protein metabolism and even affect fetal and childhood development as well. Now we'll talk about the parathyroid glands, which are on the thyroid, but it's on the posterior of the thyroid. So parathyroid glands release parathyroid hormone. Parathyroid hormone is the opposite of calcitonin in function, that it will be stimulated if blood calcium is low, then it will be released. It will cause blood calcium reabsorption in the kidneys, so it will stimulate the osteoclasts instead of inhibiting them, and in the end it will increase blood calcium and also phosphate as well. So now we'll talk about adrenocorticotropic releasing hormone, which is made in the hypothalamus, sent to the anterior pituitary gland, cause it to release adrenocorticotropic hormone, which will be sent to the adrenal glands, which lie on top of the kidneys. The adrenal glands are made up of 2 different sections, the adrenal cortex and the adrenal medulla, and they both secrete different hormones. Hormones that are released from the adrenal cortex of the adrenal glands include mineralocorticoids, glucocorticoids, and gonadocorticoids. These are all steroids ending in the word oid, and they are released from the cortex. You know that by the part of the word cortic. An example of a mineralocorticoid is aldosterone, an example of a glucocorticoid is cortisol, and an example of a gonadocorticoid is testosterone. Aldosterone will be released if sodium in the bloodstream is too low, potassium in the bloodstream is too high, or the blood pressure or blood volume is too low. And then it will cause reabsorption of sodium back into the bloodstream, which will also increase water, because wherever sodium goes, water goes, and that will, in the end, it will increase the blood pressure and volume. Cortisol is released due to stress, either physical or mental. It's going to try and get more glucose energy to the brain. So how is this steroid cortisol actually going to get more glucose into your blood? In the kidneys, it's going to cause the reabsorption of glucose back into your bloodstream. In the liver, it's going to cause an increase of gluconeogenesis, which is a formation of new glucose. It's going to cause an increase of glycogenolysis, which is a breakdown of glycogen to glucose. And it's going to cause lipolysis, breakdown of lipids, which is going to fuel glyconeogenesis and glycogenolysis. So cortisol is actually going to increase your immunosuppression. So physical or mental stress is actually going to cause your immune system to be weaker. It's also going to decrease inflammation, which is a good thing because there's more glucose in your blood. So it's going to decrease inflammation in those areas. It will also decrease digestion because your body's more focused on fueling the brain. So now we'll talk about hormones epinephrine and norepinephrine, which are released in the adrenal medulla of the adrenal glands. So they're released due to short-term stress. So for example, you have a final exam in 2 minutes and your heart is going to be racing, your breathing depth and rate is going to increase. You're going to have more blood glucose in your blood to fuel the brain, and that means there's going to be less in the gut and the skin because you don't need it there. You're kind of more in alarm phase right now. So now we're going to be talking about the 3 phases of stress. The first phase of stress is called the alarm phase. This is the one we just talked about, in which epinephrine and norepinephrine is released due to short-term stress. Second will be the resistance phase, in which cortisol is released from... Yeah, that's right. It's released from the adrenal cortex of the adrenal glands. This is more due to long-term stress. Lastly, the exhaustion phase of stress. This is when prolonged stress leads to long-term physical and psychological problems such as anxiety, depression, muscle loss, or a constant high blood pressure. So the next releasing hormone we're going to be talking about and its effects is GnRH, or gonadotropic releasing hormone. This one can cause the release of luteinizing hormone or follicle stimulating hormone from the anterior pituitary gland. FSH, follicle stimulating hormone, and LH affect the ovaries and testes and cause them to release other hormones. Testosterone is mainly released from the testes. It affects the primary sexual characteristics of males and secondary characteristics such as growth and development of primary organs or a deeper voice, etc. Estrogens are actually a group of hormones that are made in the ovaries of females. They affect various organs such as the uterus and vagina, and they also affect secondary characteristics such as body hair, wider pelvis, etc. So in the uterus, estrogens cause peristalsis in oviduct after ovulation to help the sperm go to the ovaries for fertilization. Estrogens also affect the hypothalamus in regulating GnRH through positive and negative feedback loops. They indirectly trigger ovulation by positive feedback on LH levels, which LH actually directly does trigger ovulation. Progesterone is another hormone that is made in the ovaries. During pregnancy, it's made by the placenta, but normally it's made by the ovaries. So in the uterus, it helps maintain the uterine lining for pregnancy, and high levels of progesterone actually inhibit contractions, and low levels of progesterone during pregnancy will actually make contractions occur. Progesterone affects the breast and development of mammary glands for milk production as well. Growth hormone releasing hormone from the hypothalamus will trigger the release of growth hormone from the anterior pituitary gland, and growth hormone affects various organs. It can affect the adipose cells to break down stored fat. It can affect bone cells, neurons, immune cells, muscle cells to increase their amino acid uptake and to increase their cell proliferation or mitosis. Prolactin-releasing hormone or prolactin-inhibiting hormone from the hypothalamus will cause prolactin to either be released or cause it to not be released from the anterior pituitary gland. So if prolactin-releasing hormone is released into the anterior pituitary gland, it will stimulate to act on the mammary glands to produce milk. So moving on to the posterior pituitary gland. The hypothalamic neurons in the hypothalamus will either make oxytocin or make ADH, known as antidiuretic hormone. Those will be stored in the posterior pituitary gland. When hypothalamic neurons will fire, ADH and oxytocin will be released into the bloodstream. Antidiuretic hormone is released due to a high blood osmolarity or increased salt in the blood. ADH will target the kidneys to increase water reabsorption, and it will cause vasoconstriction. Oxytocin targets the breast to release milk. It will also target the uterus to contract during childbirth. There are many other organs and glands producing hormones, such as the thymus gland, which produces the hormone thymosin. Thymosin actually influences immune system development. It's larger as a baby and it decreases in size as you age. The pineal gland will be producing melatonin. Melatonin responds to light and daily rhythms. It's released in the dark to make you more sleepy, and it actually acts on the hypothalamus to inhibit LH, and the stomach, which produces gastrin, which produces gastric juice.